Okay, what you're looking at here is sort of a long view of the main spar and the center spar of my Zenith 650 laid out in preparation for drilling the main spar and the center spars together. What I'll do is cover some of the various features of what I've got set up here and maybe a few of the tools that I've used to sort of help me set this up, and maybe this will be useful to someone that's in a similar situation. So what we're looking at here is just an end support that I've constructed, and if you can see it moving around here, there's basically three pieces of string set up that forming my reference lines for being able to make sure that the center spar and the main spar are aligned. This particular string right here on the end essentially corresponds to where the tip of the wing should be aligned at. Right now I have the spar pulled out from the center spar right now, so everything is sort of out of alignment a little bit here. Again, this could be made out of lots of different materials. I found the more I use it, how useful 80-20 really is, especially, for example, on these little alignment brackets. It makes it very easy to be able to get the positioning aligned on this. And of course, I do have this anchored to the floor. You can't see it, but on the other side there are some holes drilled in the floor here, and it was only necessary to drill the anchors on one side because this fishing line is very light, so there's not really like a whole lot of tension built up on it or anything like that. And since everything I'm measuring is in essentially a horizontal plane, I really don't have to worry about string sag or anything like that. One thing I want to make a comment on here real quick is measuring the spacing between these strings. One thing, of course, to keep in mind, unless you're very, very careful with your measuring, of course, is that this support here is not necessarily going to be parallel to the support that's on the other side. What that means, though, of course, is that this distance, I mean, if you say measure 355 millimeters here, that may not actually correspond to the distance here. Now, I mean, if you got it pretty close, you might be within a few millimeters, but of course, I'm not a good judge of what's parallel or not, so you certainly don't want to rely on that. So one thing you just want to do when you're measuring the distance between these strings, I mean, you could go ahead and rough set using these 2 points here. But one thing I would recommend doing with appropriate supports is get a right angle and line up one edge of your right angle here, and then take a measurement from the other string. That way you'll know for sure what the real parallel distance is, and of course you'll want to do that from both ends, just to make sure that you do actually have the distance that you want. Of course, now here I'm just sort of free holding this. Actually, for best measurement, you do want to have some kind of support, 3-point support supporting this right angle. Otherwise, it's too easy to of course move that string back and bump that string and move it back and forth. So I'm just showing for demonstration purposes here the use of a right angle to just make sure that you do have that distance correct. And here just showing a view of the support that I have set up for the main spar. It's the same for the left and the right side. Of course, again, making use of 80-20. I sort of demonstrated this in another video, but this is it set up in place. Now, since I do need to do adjustments, I do not have this anchored down to the floor, so it will be able to be moved. Now, just focusing in a little bit more closely, what you're seeing here is the center spar itself, and there is a little bit more going on with this. Try and get the camera centered a little bit better. Of course, you can see the examples of the anchors on the floor here and here, and there are similar ones on the other side. In this case, I mean, this needed to be firmly anchored to the floor because as I'm adjusting the main spars, of course, this thing would have a tendency to scoot around. In addition to that, I've got some additional support for this to make sure it doesn't shift around. First off, I used basically, I guess it's no-slip carpet tape on the supports underneath here and here to provide a little extra friction. And then in addition to that, there is, try and move in a little bit closer here. There is an additional support over here that I've set up, that essentially a piece of angle stock. I've got a hole drilled in here to be able to attach this to the 80-20, and of course this can pivot back and forth. And then there's also an angle, there's a lip that comes down here that I'm clamped onto. And between this and this, that's more than enough to ensure that this isn't going to move around on me while I'm working on it. And of course the floor in this shop building is by no means level, so as I mentioned in another video, one thing that really comes in handy are these lab jacks. So it makes it real easy to be able to slide it under various locations and be able to jack things up and be able to control the adjustment screws. And of course, actually right here, you can also see a little bit better view of the additional support. Again, there wasn't any drilling required or anything like that. This is just using a side clamp, and then of course, since the 80-20 has these slots in here, it came in, made it a lot easier to be able to get this adjusted. So when you're fabricating the center spar, of course, one of the things you do is make a set of spacers that help set the gap here. But in addition to that, to make sure that the gap holds in, is maintained properly, you actually want to make a few extra spacers that can actually fit inside of here. So this one, it's a pretty tight fit, but this one will fit in here. So we'll stick that spacer in there. And actually, once I get everything together and I've finished drilling the holes, what I'll do is I'll insert this spacer back in again, both here and here. It probably wouldn't be too much of a problem being able to hold spacing here, but this area back here has actually got a little bit of flex to it in the back. And especially when it comes time to attach the main spar onto the bottom of the fuselage, you definitely don't want any kind of flexing here. But of course, you do want to make sure that this spacer, the space that you do have here, matches very closely to the end of the main spar. So the tool that I use for that is what's called an adjustable parallel, and it's a machinist tool. And essentially, it's I don't know, I guess you could call it like a pair of trapezoids that sort of slide back and forth, trying to get it where you can have some decent light to see that. But essentially, you'll slide that inside of here. Get this turned around the right way, and you can use that, slide that up secure there, and then use a screwdriver to lock that in place so that it doesn't shift on you. And then once you do that, you can pull that out, and then you've got a couple of options for measuring. So what I'll do here, I'm actually using a micrometer, but there's actually nothing that's stopping you from, say, using a set of calipers. So we'll take a measurement here, and we'll see if we can get the focus set a little bit better here and try and demonstrate this. And basically these are 0 to 1 inch micrometers, and you can buy these, very inexpensively off Amazon and eBay. In fact, I mean, you're not even really trying to go so much for an exact measurement as a comparative measurement. So we'll get this set. We'll lock the arm. We'll pull this out, and then what we'll do for comparison, just to make sure, get focus reset again here. I'm running on manual focus because I have too many problems with automatic focus. So anyway, once we have this gap set here, we can use that to do a comparison against here. Now, of course, one thing you'll notice is that I've got a couple of got a side clamp here and here just to make sure everything is pulled down tight to get an accurate measurement. And of course, actually, when I go to slide this into the center spar, I'll have this clamp on at least initially until I get the initial contact. So once you've taken the measurement, then all you've got to do is just slide this on and make sure that you've got a good fit. In this case, I've got a pretty tight fit. It doesn't actually go, I guess, completely all the way across, but you want to check in a couple of places and just make sure that it fits. And of course, sometimes it can be a little tricky getting it on there, but I mean, I've measured a couple of different ways. I mean, I've done this method, then I've also gone ahead and just done, gotten actual measurements just to see how many thousandths of an inch. And for the most part, from what I recall, it's been a few weeks, but I think this was within like 1 to 2 thousandths less than the gap here, which is more than adequate for what I need to do. I think when I talked to Zenith, they said, essentially if it wasn't any more than, say, a width of a piece of paper, thickness of a piece of paper, so that'd be like 4 thousandths of an inch. So that's all I'll say about that. Again, it's come in handy for me and just provides a way to make sure that you do have your gap set. Now, in the course of this project, one thing I've always done is trying to find interesting, I guess, high-tech ways to try and make the job of putting this airplane together a lot easier. And one of the ones I'm going to use here to help me with aligning the main spar as I insert it into the center spar is this little handheld, I guess you could call it, microscope. Now, this is actually a Wi-Fi microscope from a company called, I don't know the name of the company, but it has scope around on it. I had purchased it off of eBay and of course, or off of Amazon. And of course, what makes this a little different from maybe your standard borescope type camera is that this has a right angle head on it, which actually comes in quite handy. I mean, there's definitely been occasions where, for example, I've needed to take a look underneath something and check for gap or just to like inspect screw holes and things like that. So, you may have a standard borescope, but I know the borescope I've got would have a hard time allowing me to go in here and do inspections in it. Okay, as far as being able to hold this, essentially what I've got put together here is it's not a Noga arm, but it's a Noga style arm, articulating arm that's, if you haven't seen one of these before, I mean, they do come in quite handy. I mean, it's just single arm adjustment, and then just stuck on the end of here is a 3-finger clamp, sort of like I guess what you would see in a chemistry lab. And I've just got that clamped inside here. And then we can take this and get it positioned. Big thing is just get to a point where I can see what's going on. I know the iPad is sort of off the screen here at the moment. And just get that positioned over the hole. And we'll get the camera readjusted where the iPad itself is a little bit more visible. And we'll just get this adjusted over the first hole, or at least try to. There we go. So basically the way this will work, I'll start sliding this in. I've got marks set up along here, a center line as well as where the holes will need to go. And as I slide this in, I'll look for my cross marks to appear in here. And when I had this in earlier, actually the bottom side, all of them fit within the diameter, were visible within the diameter of the hole, though actually there was a little bit of variation in some places. So we'll go ahead and get this set up, and I can go ahead and demonstrate making use of this and also getting the spar slid in. Everything pretty much in position here. I'm going to try and slide this, get this spar slid in. And of course, as I mentioned earlier, you want to have the side clamps on here just to make sure everything's down on there as tight as possible. So it's possible as I'm adjusting this that I will actually get in the way of the camera, but I'll try and minimize that as much as possible. So we've got to try and get this scooted a little more forward. Okay, there's the first side, the other side is in, so we'll just try and get this slid forward a little bit more. I can see that I'm off on my alignment just a little bit, and of course we've got this partially started. You can actually just see the edge in the display right there, and of course this display is live. So what I'll do, first thing I've got to do is since I've got the main spar inserted into the center spar now, we'll go ahead and pull the side clamps. Obviously they'll get in the way. So we've got those out of the way. And then we'll go ahead and continue on moving this forward, try and get things set up where I can start seeing the blue line and use that as an alignment guide. Step in front of the camera again here. And we'll just see if we can get this thing scooted in and into position so we can see the blue line there. And we are getting a little bit of movement there on my... Okay, so there's one line right there, but actually the line that we want, and it looks like it's off the screen, but actually the line that we want, or the mark we want, is right here. So got to keep moving forward. As long as we can keep seeing our blue line, then I should be in the ballpark. And try not to overshoot. Of course, this is also why it's useful to have this secured as much as possible. Have the center spar secured as much as possible. So, I think I just overshot. So you can clearly see the blue line there. Just got to try and get this thing moved. Okay, I think I've got about, actually another 1/4 of an inch to go. One thing that's a good idea to do is when you do have your spar in and lined up is to get an alignment mark on there. Unfortunately, when I pulled this out last, I forgot to update my mark, so it's probably the one I've got on there is probably not quite right. And we definitely overshot it there. So we'll try and scoot the thing back, and there it is. Now if we can just get it going forward again. Without having it jump. Okay, I think that's it. I think that's it right here. What we can do is we'll check the other holes and see if we've got it. It's actually, this side was the side that had the difficulties with, or was off a little bit. But we'll take a look at the other holes here. See what they look like. Yeah, you can definitely see the crosshair on that one, and we'll see. Yes, we've got the crosshair on that one. So what I'll do next is I'll check the holes on the other side. I've probably got a little bit more, no doubt, a little bit more tweaking to do, though it looks like I'm pretty much in the ballpark. but that should give you an idea of how inserting the main spar into the center spar works, and also how, you know, having this little camera can come in handy as well as far as getting the alignment. I'll show you what things look like for the holes on the other side, and I haven't adjusted anything more, but you can see that the innermost hole is pretty much dead on. The hole after that is pretty much dead on, and that one is pretty much dead on. Okay, at this point I've gone ahead and started drilling the holes for getting the center spar connected to the main spar, and you can see one bolt here. I've already done bolts on all four sides. It's sort of hidden on this side, but another bolt here, and then two more bolts on the other side. I thought I would just do a quick demonstration of actually drilling a live, going ahead and doing a live drill and showing all this being done for real. One thing you'll notice here, of course, the edge on this, of course, is not perfectly even. So for the V-block to be able to sit level, essentially some shims have got to be added in. So on this side of the on the center spar, basically, there's a difference of a 1/4 inch piece of aluminum. Along with an 032, so I've got it built up on this side. For the clamp itself, just basic C clamp. I did use some of the carpet anti-slip tape that I had mentioned before to especially prevent marring on the bottom of the bottom of the spar. Well, I've got this all clamped down. So one thing that needs to be checked, of course, once I've got everything lined up, is to make sure that that I did actually get everything centered. So again, this, if you can see the camera here, again, another situation where the scope around comes in handy. You can see where the alignment pin is, and I can sort of go around, at least where the space allows, and just make sure that I did actually get that hole centered in there. So what I'll do now is I'll go ahead and proceed with doing the drilling. Okay, I've got the drill camera shot switched around here. It just makes it a little bit easier for me to be able to, since I'm right-handed, make it a lot easier for me to go ahead and be able to do the drilling. So we'll go ahead and get a little bit of WD-40 on there, squirt a little bit of WD-40 inside the hole because we haven't drilled the hole all the way through yet. Of course, one thing to make sure of is, of course, this is good and tight. I did have this come loose on me on one of my other holes. Didn't cause any damage or anything, but but it you know, definitely don't need your drill guide jumping around on you. So we'll go ahead and get this first hole, and of course this is starting out 3/16 short bit, which will not go all the way through, but it's just to get drilled down far enough so that when I use the long bit that I have both bearings engaged. Another thing you'll notice here, I've got a little red mark on here. That just gives me a rough indication of when I have reached the end of my reached the end of my drill bit travel. So we'll go ahead and get the drilling started. Put it on high speed. And we should be down far enough. We'll go ahead and get the bit undone here. We'll switch over to our longer bit that'll allow me to go all the way through. Again, this is 3/16. Thing you want to do, of course, is make sure that that there aren't any chips on the end of the drill bit or on the end of the extension. It's only necessary to put that on there hand tight. And another thing I'll do here is just blow any chips out so they aren't getting in the way. like we're good. Put a little bit more lubricant in. A little bit more lubricant on here. And we'll take this, get the hole all the way through on 3/16. And we just went all the way through. So the next step will be to move up to the 9/64 bit before we actually run the reamer through. So again, make sure everything is clean so that the bit runs true. And we'll shoot a little WD-40 on this. Also get our chips cleared out. Everything does look clear, look good. So just spritz a little bit on here again, and we'll start the 9/64. And we're through. Yeah, the 9/64 bit, it's a little rougher going in. Maybe I'd have been better off taking an intermediate step on my drill bits, but in my testing I was getting good results just going ahead and going from 3/16 straight to 9/64. So we'll swap out for the reamer now. Again, this is the Pan American reamer with the threaded end on it. Make sure we've got no chips in the way. Get that on there, set that down, and go ahead and get our chips blown out of here. Take a peek and make sure that I've got nothing in my way that's going to interfere with the reaming. And we'll also get a little coat of WD-40 on here. We want to drop the drill bit down to low speed. Drop that in and proceed with our reaming. Okay, so that is all the way through now. So we'll go ahead and get chips cleared again. And we'll loosen it up and see what we got here. And it looks like we got a nice clean hole. So we'll blow this out one more time, make sure we've got all the chips out of the way. And we should be able to drop that in there. And we've got a nice solid fit. Okay, a couple of other things that I'll point out here as far as what I've learned so far with doing the drilling. Of course, as I mentioned a second ago, you've got this step right here that essentially consists of a 1/4 inch thick piece of stock, plus then this is 032 metal on top of that. So there's not enough space for the drill jig to sit stably, so you'll need to shim that up. And then similarly, when this center hole was being drilled right here, again, it wasn't practical to put the drill jig on this side just because of the difficulty of getting through on the clamps. So it was necessary to put it on this side, and you have a piece of 040 metal on that side. So again, you'll have to add a little extra piece of metal on the side here to be able to provide a stable surface. Now, one other thing you'll run into that one thing you'll encounter is when it comes time to drill this hole, again, because of space constraint or at least the limitations of the clamps that I've got, it's not practical for me to clamp in from this side. So actually it's necessary for me to clamp on this side, but of course, as you can see, this bolt is in the way. But in the course of doing all this drilling, of course, I want to have, every hole that's already been reamed out, I want to have a bolt in place so that there's not a chance of any shifting causing problems with the holes being getting misaligned, since we're talking tolerances of basically almost pretty much interference tolerances on this. So what I did is I sacrificed one of my bolts to basically make a pin that I can drop in to here. So when I do actually drill this, I can drop that in there. That'll ensure that nothing can shift inside here, and then I'll be able to clamp down from this side here and be able to drill my final hole. So that's all I'm going to cover as far as the actual drilling itself. Well, at this point, I'm happy to report that all the holes have been drilled, and I believe successfully. Everything is still within specs as far as maintaining dihedrals, so this particular operation consider to be a success. So I mean, this is looking at the left-hand side of the center spar, and then just translating over here. We can also see the right-hand side of the center spar with all the holes drilled in. This is a view of the right-hand center spar main spar, showing the main spar pulled out, and of course with the bolts removed, and from what I can tell, everything looks quite nice. One thing I did want to point out here that I didn't think about when I was actually driving these bolts out, I wasn't going to bore anyone watching me just hammering a bunch of bolts out, but one thing you do want to keep in mind, of course, is when you're hammering these out, and I mean, they're not like super tight, like press fit tight, but I mean, some of them were a fairly snug fit, which is what they should be. But one thing you don't want to do is hammer on these bolts with a hammer like this, because obviously that would deform the end and the threads, and possibly could cause stress regions that might cause the bolt to fail or something. So when I was removing these, getting these bolts out, basically I just used a little rubber-faced hammer. And like I said, most of them came out with very little trouble. I had one, I think, in this hole right here that was a little tight, but when I looked at the bolt, I saw what looked like may have been just a little burr of metal in there that got stuck from the drilling that didn't clean out properly. So as I continue taking things apart here, I'll show a few more details of how these stands were constructed. Of course, this is the stand that had the center spar in it. I think probably the two biggest things that I just want to point out here, first off, is the use of the diagonal piece right here that fits that attached onto the upper lip that came over, or that sort of comes over the top of the center spar, just attaching that with a basic side clamp. And then the other thing is the use of the anti-friction carpet tape. Again, the two main reasons for using this, first off, it provides some protection against scratching from the corners, even though I did round over the corners of my 80-20. But of course, the other thing is that it does provide a little bit increased friction grip, and so between the anti-friction tape and the diagonal brace here, I had no problems with the center spar trying to shift around on me or anything like that. At this point, I've got the main spar and the center spar moved back into my other building, and what you're looking at is an in view of the center spar sitting up on a table here. Just wanted to point out one little issue I hadn't really anticipated, but I should have maybe expected. So I just wanted to go ahead and point this out real quick. This is the bottom view of the center spar right here, and what's happened is you'll notice that this is sort of raised up a little bit, and essentially what's happened is some metal burrs have, from the drilling, have essentially wedged themselves up inside the sheet metal here. I'm not sure if there was any way I could have really avoided this. I'm not sure if I could have gotten some kind of backer in here or not, because I also had the requirement of making sure that these pins or that these holes maintained alignment. But still, the solution to the problem is easy enough. Essentially, this is a feeler gauge here, 1/4 millimeter. And so all I've got to do, I've already done it on one side, but all I've got to do is just run that feeler gauge up underneath there, maybe raise the end of this metal up a little bit here, and just get all those burrs pushed out of there, and then this should drop back down. I've already cleaned up the other side, and it dropped down just fine. So I just need to do the same thing here. I just wanted to go ahead and mention this in case someone does their drilling and suddenly notices this, thinking that there might be some kind of a major problem, and of course it really isn't. It's just some metal burrs got up in there, and of course if you are doing something similar, then at the very least give you a heads up of a potential problem area, so that maybe you can just avoid it altogether by having some proper backing, or maybe a little bit better clamping on this area here to make sure that this doubler stays down tight. So after spending a couple of minutes working with the feeler gauge, I think I've managed to get all the metal burrs pulled out. In fact, you can even see an example of one right there that I managed to pull out. Any gap that you're seeing there now really is just the metal not being absolutely perfectly flat, and just a little bit of flexing pulls everything together. So I'm pretty confident that we're good to go on that now. So at this point, this is all I'm going to cover on drilling the main spar and the center spars together. If you're a builder, hopefully maybe this has given you some ideas on how to proceed through this, I would call sort of important and intimidating part of scratch building an airplane. And if you have any questions, feel free just to post a comment, and I will do my best to answer.